Alright guys, so we are going to start talking about something new. One of my fave things, we're going to leave triangle land and enter polygon land. So we're going to be dealing with bigger shapes. For today, we're going to be looking at all shapes that are larger, so all polygons that are bigger. But then we're going to narrow our focus down to just quadrilaterals, which are four-sided figures. So these were the notes that I was talking about in the assignment posted. So if you can print them, that's great, and you can add them to your notebook. But if not, I'm going to work on those in a second, and you can fill them out the best you can. But I wanted to think about something with you. So one of the most important things that we learned about a triangle is the Triangle Sum Theorem, which says that all of the angles inside of a triangle add up to equal 180. This is a theorem that we proved. It's a known fact. So once I start getting to bigger shapes, we can use that theorem, because we know it to be true, to help us find the sum of the angles in larger shapes. So for example, when I bump it up by one side length and now I'm a quadrilateral, I can draw a diagonal, so corner to corner, and I end up with two triangles, which this one will sum to 180 and this one will sum to 180, for a total of two 180s, so 360 degrees. Now just remember with me, you know, this is three sides, four sides, and then if we talk about a five-sided figure, that's called a pentagon. Just like with the last one, I can draw in from a corner to another corner a triangle, and then using that same corner, when I do this, I finish it off and I get two more triangles right there. So you end up with a triangle right here, which will add to 180, triangle here, which will add to 180, and a triangle here that will add up to equal 180. And so I end up with three 180s, and three 180s is 540 degrees for a five-sided figure. And then we can bump it up again, and if I do six sides, we have a hexagon. And so just like with all the others, if I start from a corner, any corner, I can draw right here to get a triangle. If I go anywhere else, it'll be too big. But then same corner, I get another triangle right here, but this one is still not a triangle, so I have to go one more, and now we have only triangles. And when I do all of those, I end up with four triangles, so 180 here, 180 here, 180 here, and 180 there. So I end up with four 180s for a total of, big numbers now, 720 total degrees in a hexagon. And so we could do a 7-agon, which is called a heptagon, but I couldn't draw it, so I went with 8. That's an octagon, because that's just a stop sign. And just with all the others, I can start drawing in my triangles, and again, I can start at any corner. So maybe I'll start at this corner. Now I have to go here to here, because anything else would not be a triangle. Triangle, 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 triangle. And so each triangle in there, and it's getting kind of small, so I can't fit them all. I got 1, 2, 3, 4, 5, 6 180s for a total of, oh my goodness, big math, getting my calculator and won't even lie to you about it, 1080. So total of 1080 degrees in there. Now, kind of noticing something here with the pattern, when I had four sides, I had two 180s, five sides I had three 180s, six sides I had four 180s, and eight sides I had six 180s. So if I had to guess, when we have 7 sides, I'd bet you there would have been 5 180s, because I'm noticing that however many sides I have, there are always 2 less triangles. So like 6 minus 2 is 4, 8 minus 2 is 6, 7 minus 2 is 5, And so that seems to be a thing. And it even works with the 3. 3 sides minus 2 is 1/180. And so for that 7-sided heptagon, 5 times 180 is 900. And so using that fact, we've actually come up with a formula, which is called the Polygon Interior Angle Sum Theorem. Okay? So just as a reminder at the top here, if I have 3 sides, then I am a triangle, then we are a quadrilateral, pentagon, hexagon, hexa for 6, hepta, which if you're into like, I'm pretty sure Greek mythology, hepta is a, I don't know, maybe. 8 is octagon, 9 is nonagon, which I will also post an amazing YouTube video for you to watch about nonagon. It's amazing. 10 is a decagon. I always forget 11. I don't know it. Look it up. It's got a weird name. But 12 is fun. It's a dodecagon. So like 2 and 10. So dodecagon. So have fun. Okay. So the theorem that we just kind of discovered here in our drawing down below is that the sum of the interior angles of any polygon with n sides is n minus 2 times 180, where again n is the number of sides. It was always 2 less times 180. So for example here we'd have 3 minus 1 because I have 3 sides. 3 minus 2 times 180. So 1 times 180 for 180 degrees. Here I have 4 sides, so 4 minus 2 times 180 for 2 times 180, which is 360, which I feel like we already knew that for a quadrilateral. And for that last one, the cute little pentagon, we got 5 sides minus 2, and I can just count 1, 2, 3, 4, 5 sides. Just don't lose your count. And we got 3 times 180, which we said before was 540. Now it's pretty easy to find all those, and I'm not asking you to memorize them, that would be insane. So if I were to add some math to it now, I just need to know how many sides I have. So in this shape here we have 5 sides, so if I add all these, so the 3x minus 5 plus x plus 10 plus 4x plus 8 plus 12x plus 6x plus 7. If we add all of those, that is the sum of the interior angles. And to find it for a 5-sided figure, I have to do 5 minus 2 times 180. Now I know we've already done this a couple of times, but it's silly to just have that number memorized. I can always find it by doing number of sides minus 2 times 180. Once we have that set up, I already did that math here, so it's 540. On this side, if I combine all my like terms, I got 3x, another one here, so 4, 8, 20, 26x, and then combine all my non-x's, so 5, 13, 20, and then just solve for x, so subtract the 20 for 520, and then divide by 26. Oh my gosh, I hope it goes evenly and it's big numbers again. I won't even lie to you, I'm grabbing my calculator. 520 divided by 26 is 20. So we found the value of x. Love it. Alrighty. Now, in addition to that, we can also use that to our advantage if we want to find the number of sides. So if the polygon is what's called regular, regular means everything is equal. So all sides and angles are equal. We can do the n minus 2 times 180, which will get me the sum. And if I want just one, so one angle, then I can divide by however many I have, which there are n of them, because if there are n sides, then there are n angles. So this is another little formula that can really help us here. Okay, so in this first example, if the measure of an interior angle is 150, so I know that one of them is 150, so we have n minus 2 times 180 over n is how we would get that, and then we just have to solve for n. So I'm really uncomfortable about the division here, so I'm going to first times n on both sides so that that's gone. So I'll have 150n equals n minus 2 times 180. Now I need to get my n's on both sides, but I can't really move this one yet because of the parentheses, so I'm going to distribute. So I'll have 150n equals 180n minus 360. And then we just want to combine like terms and solve for n. So I would actually subtract the 150 for 30n and then add the 360 just because I like things to be positive, and then divide the 30, so n is 12. So the number of sides that I have is 12, which is a dodecagon. Okay, so that's kind of how we do that one. And then I think I'm going to leave these three for you to maybe try, or maybe I'll try them again later. This last one here has to do with the measure of the outside angles. So if I have a polygon like this, you can extend each of these sides so that you get this sort of exterior angle on the outside of the shape. Now you don't necessarily have to extend them in this way, you could have gone the other direction as well, but you don't want them coming off both ends, so like you don't want it here and here, or like here and there. You just always want one little extra little hangy piece, if that makes sense. And I don't know if you're noticing a thing, but it kind of looks like it's going in a circular sort of motion, and so hopefully that helps us to understand that the sum of the exterior angle measures of any convex, so outward facing polygon, with one angle at each vertex is 360. So that's really just saying this is angle 1, 2, 3, 4, 5, 6, and it doesn't matter if there are 6, 7, 9, whatever. The sum of them will always be 360. If I want just one, and I'm regular again, that means they're all equal, and since the sum is 360, if I just want one of them, divide it by n, because n is how many I have, so that will get me just one. Okay. Now another way to think about it is we can also consider the fact that this angle here and this angle here are a linear pair. So if I know the inside one, then I can just subtract from 180 to find the outside one. Or like I said, you can divide 360. So for example, actually going back to this one, it's a hexagon. So we would do 360 divided by 6, so each exterior angle is 60 degrees. Which that's nice because if I know the outside one is 60 degrees, we can know the inside one. And the other formula is a little bit harder. So now I know the inside one is 120 and I don't have to like do this formula. But again, the other way to do it, so for this pentagon here, we could do 360 divided by 5, which is not going to be super pretty. Oh wait, no, yeah, 72. So 72 is the outside one, and then I could find the inside one. It'd have to be 108. So yeah, either way, super fun. So try those other ones, you guys, like I said. Yeah, I think that's good. Good luck.